Hey everyone. Sorry I'm not there with you today, but when you came in today, you should have received this homework back from last week. And then hopefully you got a few minutes to work on it or look at your answers with someone else. If you didn't turn this in originally, then you should have at least grabbed one of the blank copies that's up there and then got started on it in the last few minutes. Then you can finish it while we do it together right now, real quick, and then everyone's going to turn it back in. I have not graded these or checked them in or anything. Um, so if you didn't do this originally, you got kind of lucky, right? Because then now you can turn it in with everyone else and get credit for it, which is a good thing because the grading period ends at the end of this week. So if you're missing assignments, get those to me before the end of the week. If you need to retake any quiz, whether it's the one that we're going to talk about today later in this class period that you took last week or any other one, like you want to try to get that SVP grade up, come Thursday to my class after school. We could do whatever retakes. So remember, this assignment here is meant to prepare you for the SBA test. That's the big state test that you will take in May. That's still 2 months from now. So we don't have to be like stressed out about it right now or anything. But it's good to be preparing well in advance. So that's what we're preparing for here, looking at some of the old stuff we've done, this proportional relationship stuff. And so the first one says, Michelle bought 5 packs of crayons for $13.75. So what is the cost of a pack of crayons in dollars if all packs cost the same? So the fact that it says in dollars is a little weird. I hope that doesn't make you feel like you have to have a whole number answer, like you can only have dollars, no cents. In dollars could also mean $2.75, or which would be $2.75, right? So what we're trying to find is a unit rate, the cost for 1 pack of crayons. And that was something we did a lot of earlier, way earlier this school year. And that's just going to be 1375 divided by 5. Now, I want you to notice that this question doesn't have a little calculator symbol on it. And so I'm not 100% sure, but what I think that means is that if you were doing this question on the test, you would not have a calculator function available to you. And the way this test works is like a couple days before the test starts, the school puts all the Chromebooks in this special mode where like you can't go into other tabs to sort of like, oh, I'll just Google the answer to 1375 divided by 5 or whatever. You won't be able to do that. So you're going to have to actually be able to do this question with no calculator tool in the test and no Google tab to be able to do this division that way either. So a few times during the school year, we practice long division like this. And so let's look at it one time real quick. 5 goes into 1 0 times. So we put a 0 to indicate that. 5 goes into 13 2 times. 2 times 5 is 10. We subtract down, we get a 3. I notice that I'm at the decimal point here. So let me put the decimal point up in my answer. Let me bring down this 7. 5 goes into 37, 7 whole times. 7 times 5 is 35. Oh, it looks like the answer is going to be 275. And I said that randomly earlier. I subtract down and get a 2, bring down this 5. 5 times 5 is 5. So the answer is 275. Let me go grab a different marker. This one, the ink is running out. I'll be right back. All right, so let's do the next one. It's about scale drawings. This one's really easy. I hope everybody in class got this one. Remember, we just need a scale factor that's going to take figure A to figure B. I noticed that it says figure A to produce figure B. If it had said figure B to produce figure A, I would be looking to draw that arrow the other way, right? And so really this is just what number is all these sides being multiplied by? 7 times 2 equals 14. Or you could do it as new shape divided by original shape. That was another way to get that same answer. 14 divided by 7 equals 2. Either way, the answer on this one was 2. I hope that was an easy one for everyone. Let's move on to the next page. So some of these other ones have this calculator symbol. And so I believe that indicates to us that if you were on the test, you would have a calculator function like to use within the test. So let's find, it says select the table that represents proportional relationship. So that makes me believe that there's only one correct answer here. I notice that they all have 0, 0 for the first X and Y. Remember, we need that for proportional relationships. If you have a 0 and anything other than a 0 next to each other, right there, you can conclude that that is not a proportional relationship. So we check for proportionality by doing our Y divided by X ratios. I would draw an extra row at the bottom of these boxes so I could do it there, but there's not enough space. So I'm just going to do a bunch of little side calculations over here. Y divided by X would be 3 divided by 1, which equals 3. Okay, so they all have to turn out to be 3 in order for this to be proportional. 6 divided by 2 is 3, and 9 divided by 3 equals 3. This one is proportional. If you wanted to be very thorough in your work, you could go and check the other two, but I'm pretty confident that they're not going to turn out proportional. In fact, I can tell just by glancing at them real quick, but also I'm also confident because I know that there's only supposed to be one to select. The next one, on the other hand, says select all tables that represent a proportional relationship. And so on this one, we do need to check them all to make sure that we're making all the right selections. I think this one gives me enough room. So on the bottom of each one of these, I'm just going to put a new row that represents the Y value divided by the X value for each one of these columns. And so I'm not going to bother writing that Y divided by X for each one of these though. I just expect you to understand that in each one of these, I'm doing Y divided by X. So 9 divided by 1, 9. 18 divided by 2 is 9, and 27 divided by 3 is 9. So this one is proportional. I would select it. Here we have 21 divided by 3, that's 7. 42 divided by 6 is 7. And 63 divided by 9 is 7. This one is also proportional. Remember, this is our constant of proportionality. When all these ratios that I'm calculating out turn out to be the same or constant, then that's how we determine that it's a proportional relationship. Here, look at this. Look at this 1, 0. I should have noticed this when I was making the boxes. I shouldn't even, and look, 0, 2. Oh, we don't even have to do any math on these two. Just the fact that I have a 0 value for either X or Y, and then a non-zero value for the other X or Y, we don't even have to go any further. Not proportional, not proportional. Let's move on. Okay, figure B is a scale image, scale copy, scale drawing. These all mean the same thing. Of figure A. Let's find the scale factor and round to the nearest hundredth. So I want to do the new divided by the original. Remember, this is the same as like doing Y divided by X. And so the scale factor is going to be whatever 44 divided by 12 is. This one has the calculator symbol, so might as well do it that way, right? 44 divided by 12. So it looks like it's 3.6 repeating. It says I need to round to the nearest hundredth. So that's the second decimal place, the second 6 right here. And so it'd be tempting to write 3.66, but the third 6 is greater than 5. And so that forces the second 6, the one that we care about, to round up to a 7. And so what we have here is 3.67. Right, on the next one, look at these fractions. So my strategy on this one would be a little different than it was on the previous ones, where I was doing Y divided by X for each one. So I don't want to do all those division by fractions. Instead, I notice that the denominators are the same left to right on like all these. And that's way easier to deal with moving left to right with the denominators being the same rather than trying to divide by fractions repeatedly to do Y divided by X. And so the other thing I know about proportional relationships, other than the fact that the Y divided by X ratios have to be the same, but I also know that if, for say, this value from going from 1 to 2, if that doubles, then this must also double. If 1 times 2 is 2, well then 2/9 times 2 needs to go here, which would be 4/9. but this is 5/9. And so the ratios are out of whack. This number doubled, this number more than doubled. That's enough for me to know it's not proportional. Another thing I notice about this question is that it says select the table. So this is good. It's still a good idea to check every single table, like when you're really on the test, because you want to be super thorough and make sure you get it right. But for our purposes right now, just practicing, I could probably just find the one that is proportional and move on. So let's use the strategy again. To go from 1/2 to 2/2, that's a doubling again, right? This is times 2. So that means right below it better also be times 2. But 1/4 to 4/4, that's times 4. These are different ratios, not proportional. Next, on C, I noticed that to go from 2 to 4 is doubling again. So this value directly above must also double. 5/8 times 2 is 10/8. But they've given me 1 and 1/8. That's the same as 9/8. That's not double. It needed to be 10/8. So not proportional. So at this point, I'm pretty sure the answer is D. Let's just check it though. 1.5 to 3 is a doubling, and 1.5 to 4.5 is a tripling. So let's see if we have the same pattern below. 1/4 to 1/2 is a doubling, and 1/4 to 3/4 is a tripling. And so that the ratios are the same across the top and across the bottom. There's my proportional relationship. On the back, it says, Pauline made a graph to show a relationship between the number of ounces of chocolate and the number of ounces of butter in a recipe. And I look at this graph and I notice, oh, this is the point. Well, I guess I can't really see that point very well. I can see this point really well. This looks like it's 3, 2. The X value first, and then the Y value. This one looks like it's crossing right on where the two lines meet. And so that's like a good point to me. And so if this is a Y value and this is an X value, then I know my K, my constant, my unit rate, whatever you want to call it. I think in this question, they're asking us about unit rate. Remember, those are the same thing, right? K equals the unit rate. And that's going to be Y divided by X. So 2 divided by 3, which is 2/3. I can just write it as the fraction, 2/3, 2 divided by 3. Okay. Well, let's see here. Let's see which ones of these sound right. Unit rate is 1/2 of an ounce per butter, ounce of butter per 1 ounce. No, it's not 1/2 to 1. It's 2/3 to 1. This is the unit rate. So this is how much you get per 1. This is how much chocolate you get for every 1 ounce of butter. No, sorry, I misspoke. That is how much butter you get for every 1 ounce of chocolate. And you know how I caught myself that I knew that I was wrong? Is that I noticed that the Y value is less than the X value, and this is less than 1. So it makes sense for this to be how much butter you get for every 1 ounce of chocolate. Okay, so maybe B is right. I see 2/3 in the answer for B. So let's see here. 2/3 ounce of butter. Good. That's the y-axis. That's the smaller value. I think that feels right, because the graph passes through the point 3, 2. Oh yeah. I think that's probably got to be right? I mean, let's look at the other two statements just to see. But the unit rate is 1 ounce of butter per 1 ounce of chocolate. No, it's not 1-to-1. Okay. And then the unit rate is 1.5 ounces of butter per 1 ounce of chocolate, because the graph passes through the point 2, 3. So you would get this answer on accident wrong if you got your X's and Y's mixed up and thought it was 2, 3. So I think we got to go with B. The last one says that this equation here represents how much profit is made, P, for any number of hot dogs sold, H. So P is the profit. And the profit represents dollars, right? If the profit is 10, then that's $10. If the profit is 20, that's $20. and H is number of hot dogs. You don't even have to do any math to get this answer. The answer is like actually literally right there in front of you if you remember how to read these equations. But let's like test it out just so people can understand it. If I sell 3 hot dogs, that means H equals 3. And so then the profit would equal 2 times 3. That's 6. Okay. If I sold 5 hot dogs, then it would be 5 times 2, and the profit would be $10. Whatever number of hot dogs I sell, I just multiply by 2, and that's my profit. So in other words, each hot dog gets me $2. That's the unit rate. How much profit per 1 hot dog? And the unit rate is the same thing as K. And remember, these equations always look like something equals K times something. That 2 right there is your K. That 2 is your constant, it's your unit rate, it's how much profit you're getting for every 1 hot dog. So the answer was just right there for you. If you know how to read this equation, it's 2. All right, what I'd like to see happen now is collect these back, and clip them and leave them back up at the front so I can look at them when I come back. And then let's hand the quizzes back from last week. We can have a couple of student volunteers do that. If you're not comfortable with a student handing back your quiz, then maybe you could just tell to substitute that and they could try to find yours from the stack real quick. But otherwise, let's have 2 or 3 students hand the quizzes back. Whoever's teaching the class right now could just pause this video. And then once everybody has their quiz, go ahead and unpause the video, please. Okay, so the quiz. It was graded out of 13 points, but there was a maximum of 14 because everyone got a free point. I don't really have much else to say about the scoring other than if it looked like you kind of knew what you were doing and you just messed up because you like added wrong or multiplied wrong or got a positive or a negative wrong in there somewhere, then I give you half a point for that question. But other than that, they were all 1 point each, except for 3 was worth 2 points because you had to give me 2 expressions, 1 point each. And question 4 was worth 2 points just because I felt like it was a little bit harder than some of the other ones. All right, so negative 7a and 4a. Let's do negative 3a. 3b and negative 2b gets you 1b. And then you got your plus 2 there. There's that. Here you need to distribute the negative 2 into the first set of parentheses, then distribute the 3 into the second set of parentheses, then you can combine all the like terms. So we get negative 4x plus negative 6y plus positive 14 plus 3x plus 3y. Now I can combine the x's. Negative 4 and positive 3 gets me negative 1x and negative 6y and I realized, I was like, wait, I know the answer is supposed to have a negative 9y in it. What did I mess up? This should be a plus negative 3y right here, or a minus 3y, because I have that minus sign in front of the y there. So now I've got negative 6y and negative 3y. That comes out to negative 9y. And lastly, I've got this plus 14. Okay, here, the only terms I see in this entire expression that could really ever be combined is this 12 and this 13. So my goal is to get those together, but I can't do it as long as that 13 is trapped in this parentheses. So this says 12 minus all the stuff in the parentheses. If you multiplied this 12 by stuff in the parentheses, you only do that if the 12 is right up against the parentheses. This minus sign separating them tells us not to do that. And so I'm going to distribute the negative. The negative sign touches the 2w and becomes minus 2w. The negative sign touches this minus 4m and becomes plus 4m. And the negative sign touches this negative 13 or minus 13 and it becomes plus 13. And now I can add the 12 and the 13 and get 25. Got a lot of negative ones out there because people didn't change that minus 13 to plus 13. All right, lastly, you needed to add the fractional coefficients of this. I don't want to go through adding fractions right now for the sake of time. You should have got 1/4 x plus 5/4 y. If you got anything other than that, you probably just messed up adding the fractions. A lot of people didn't notice that minus sign in front of the 1/4 x there. Okay, here we want to factor out a 4 and get x plus 3 in the parentheses. I found out that there was a 4 inside this 4 and inside this 12. So I divide it out and I'm left with 4x divided by 4 is x and 12y divided by 4 is 3y. I'm forgetting a lot of my letters. I'm trying to go fast. You also could have factored out a 2 and then get 2x plus 6y. Here, I want to group some things together. I have 2 of this quantity a plus b, and I have another a plus b, for a total of 3 a plus b's. And then I have 1, 2, 3 h plus k's. So plus 3 h plus k's. And if you went a step further and wrote this as 3 times quantity a plus b plus h plus k, great job. But this is all I required for full credit on this one. Here, I notice that there is a common factor of 3 inside 27, 45, 60, and 15. So I start by writing a 3, open my parentheses, and now it's just each one of these things divided by 3. I get 9m, 15n, 20w, plus 5. Here, you kind of have to do 2 steps. Let's add up all the a's and b's first. So I have 4 a's and 4 b's and a 4. 4a plus 4b plus 4. Now I notice that there's a common factor of 4 in all of these terms, and I can write 4 times 1a, 1b, 1. I need to write 2 equivalent expressions that represent this rectangular array. Let me do the multiplications first. 7 times 2d is 14d, and 7 times 4 is 28. And so I get 2 expressions. One is in factored form from the outer numbers. If I wanted to find the area of this rectangle, I could do this 7 times these 2 lengths added up, 2d plus 4. Another way to find the area of the rectangle would be to just add this area plus this area, and that gives me the same expression I would get if I distributed this 7 through the parentheses, and that's 14d plus 28. Here, each room is x feet wide. So this is an x, this is an x, this is an x, and this is an x. And then the walls are an extra 1 foot thick each. So this is a 1, 1, 1. If you add all this stuff up, you have 1, 2, 3, 4x, and then plus 3. And lastly, it says calculate the length of the room if the building is 103 feet long. So you've got this building that is 4x plus 3, and its total is supposed to equal 103. Now, we hadn't practiced this yet at the time when you took this quiz. That's why I made the numbers really easy, hoping you could just kind of see how to solve it. But now that we've been practicing it, you should see that you could just go subtract 3 from both sides and get 4x equals 100 and divide both sides by 4 and get x equals 25. So each room was 25. Okay, so let's see. Let me check the time, how long this video has been. Okay, so we should be a little over 30 minutes into the period at this point, maybe 31 or 32. So there's probably like 15-ish minutes left in the period, depending. I'd like you to get into Desmos and do an activity called pentomino puzzles. Whoever's leading the class right now, if you could pause this video now and then play the rest of this in the last few minutes of class, that'd be great. Okay, so I'm borrowing someone else's computer, and so what I needed to do there took me a moment. So whoever's leading the class, if you played that sort of like silent portion during first period, maybe you could fast forward through that in other periods. But I just want to talk about how you could algebraically represent what's going on with these pentomino puzzles real quick for the class ends. So let me see if I